Hello, welcome to my lab. Today we will investigate the environmental effect on mitosis. What is the objective of this lab? It is to observe the effect of the caffeine on the rate of mitosis, and caffeine will act as the environmental factor. The rate of growth of the onion roots will be observed and quantified when it's exposed to the environmental chemical caffeine in the form of coffee. So here are the materials. Here in our materials we have the microscope slides, we can see here. And on the microscope slides we have the microscope cover slips, which are very small but can be seen. We have the microscope right here, and then we have the one onion in the caffeine solution here, and one onion here in distilled water. Then we have our 0.5% aqueous solution of the Teldin blue. We have our 0.1 molar solution of the hydrochloric acid. And that was it for our materials. And now we get to the procedure. So how we conducted the experiment was, first we had the onion bulbs. So these onion bulbs, we grew them in water, and we let the roots grow 1 centimeters in length. And after both onions had their roots 1 centimeter in length, we took one onion and placed it in the caffeine solution right here, and we left this one right here to just keep on growing in the distilled water. We harvested the root tip of the onion bulb in water, in distilled water, and in caffeine, and placed the root tip separately in the beakers with 5 drops of HCl. We then dried it up. So after placing it in HCl, we left it to dry, and once it was dried up, we added the 5 drops of toluidine blue to each of the roots and left it to dry again. And that's when we used the squash technique here on the slides. And in the squash technique, the slide was placed on paper towel cushion, and the slide and the cover slip, they were covered with the paper towel. So then, using eraser of a pencil, the section with the root tip was pressed hard straight down without bending or rotating it. And this squash technique was used for both of the caffeine of the onion in the caffeine and distilled water. And now we're gonna observe the slides, these two slides, under the microscope at 10 times and 40 times power to observe the cells undergoing mitosis. So now we adjust the slide a bit so that we center it out and we get a clear view of the mitosis in the root, the onion root. Okay, so now that we've observed the onion root grown in distilled water, it's time to change the slide and observe the onion root grown in caffeine. So we will place it properly, the microscope. Now that it's well placed, we adjust it, again centering it out and observing the mitosis stage that is happening in the onion root. Yeah, this is a clear overview. You can see it very nicely. Okay. So now that we've observed the roots grown in distilled water and caffeine, it's time to look at the results and look at the analysis and reach to a conclusion. Okay, so now to our results. So here in the picture we see the different stages of mitosis and of course interphase under the microscope, and I sketched it here in the picture. Here we see there's the interface and its corresponding picture, how it looks like, and then I made it for prophase, metaphase, anaphase, and telophase. I left cytokinesis out because I didn't find it in any of the cells. So now what I did was I made a data table, and here in the data table I noted down how many cells I found were undergoing the different stages. So in water I found 49 cells interphase, 4 prophase, 4 metaphase, 2 anaphase, 4 in telophase, and 0 cytokinesis. In the caffeine solution I found 53 cells undergoing interphase, 4 prophase, 2 metaphase, 2 anaphase, and 2 telophase. So now to this data table I made a bar graph so that we can compare the stages in caffeine and water, how they relate to each other. The water is the control and caffeine is our independent group. So in the interphase we see there's more in the caffeine we see there's more interphase than the water. Prophase there's more prophase in water than caffeine. Metaphase is more in water than caffeine. Anaphase is about equal in water and caffeine. And telophase, there's more telophase in water than caffeine, and there's no cytokinesis. So now what I did was, we know that prophase, metaphase, anaphase, telophase, and cytokinesis, they're all part of the mitosis, and interphase is another stage, considered another stage. So I just added all the stages of mitosis together and put it as one column, mitosis, mitotic cells, and on one side interphase cells. So we found 49 interphase cells and 19 mitotic cells. So there was a total of 68 that we found. Interphase cells in the caffeine were 53, 10 mitotic cells, and total we found 63. And now that it's very important that you have the totals approximately equal to each other, because then it's much easier to compare. Else we will still make it more exact by looking at the percentage, and that way everything is kind of more equalized. So again, we made a bar chart, and here we see the interphase compared to the mitosis, interphase and mitosis in the water versus the caffeine. So here we see that caffeine had much more interphase going on than water, but in water there was much more mitosis taking place than caffeine. But the total was also approximately the same, so it's a good comparison. Okay, so now to our analysis. So from the observed data in table 6.2, the percentage of cells involved in the mitosis and interphase were analyzed for the caffeine-treated routes. So percentage of cells in mitosis for the caffeine solution is 10 over 63 times 100. We want the percentage, which is 16%. Now why 10? 10 is, if we look at the data table, we see 10 in mitosis, and out of the total of 63 cells, so that's how we calculate the percentage of cells in mitosis. In interphase, we know that mitosis interphase make up the total, which is 100%, so from 16% we know interphase must be 100 minus 16, which is 84%. Similarly, we find the percentage of cells in mitosis for water as 19 out of 68 cells times 100, which gives us 28%, and therefore percentage of cells in interphase for water are 72%. So there's a significant difference between the percentage of cells in mitosis and interphase for water and caffeine solution. If caffeine had no effect on mitosis, then the number of cells engaged in mitosis should be similar to the untreated root type, because it's the control group. So it is further, now we'll further analyze with the chi-square test, which is a distribution to perform the goodness of fit test to determine whether to accept it or reject the null hypothesis. So the null hypothesis will assume that caffeine had no effect on mitosis for the observed data at a 5% significance level. That's what we want to look for. So for the chi-square test, some additional expressions are then calculated now in table 6.3. Here, the percentage of expected mitosis in caffeine is, we know there was we calculated it as 28%. So, and we knew that the total is 63, so 28% of 63 is 18. And now similarly, percentage of expected interphase in the caffeine is then 72% times the total 63, which is 45. So now here in table 613, we see that observed interface cells were 53, but according to the percentage we found, we expected 45. Mitosis observed was 10, and we expected 18. So now what we do is, for the chi-square test to work, we need to first find the observed value of interphase and mitosis cell and subtract expected value from the observed. So O minus E in this case, which is 8 for interphase, and for mitotic cells, it's negative 8. And now we square it because we want it as the positive value, and we get 64 for interphase cells and mitotic cells. So now we use this formula of the chi-square calculation, and we find that it is O. So we find O, the summation of O minus E whole squared divided by E, where O is observed and E is the expected, is 64 divided by 18 plus 64 divided by 45, which gives us a chi-square value of 4.97. Okay, so now the chi-square distribution is not symmetrical, rather it is skewed. So the 5% of significant level implies that the area of 0.05 in the right tail is used as the rejection region, or the region that is not accepted. If the chi-squared value falls in this region, then the null hypothesis is rejected. The line which separates the rejection and acceptance regions intersects the x-axis at the critical value, which we denote as CV. So there are two categories used in the chi-squared: the interphase and the mitotic cells. And here we'll also consider the degree of freedom, which is one less than the number of categories. So in this case, we have interphase and mitosis. So there are two categories. One less would be a degree of freedom of 1. So the chi-square distribution table for 1 degree of freedom and for area of 0.05 has the critical value of 3.84, which we found using the table. And here in the graph we see that 4.97 is greater than 3.84, so it lies on the right side of the critical value, corresponding to the rejected region in the chi-square distribution. So therefore, the null hypothesis is rejected, and we can prove that the caffeine did in fact have a significant effect on mitosis for the observed data. So we can conclude that the environmental factors impact the rate of mitosis in plants, and as observed in this investigation, presence of caffeine does in fact affect mitosis process adversely. And as we experimentally tested that caffeine had an effect on the number of cells involved in mitosis, the percentage of cells involved in mitosis decreased almost by half.